Hi, I'm Alistair. In my last video I showed how you could use Node-RED to create a web page that updated in real time to show the values sent from an Arduino. Now in that example the Arduino just had a single input, which was a read switch, and that read high or low depending on whether a magnet was close to the Arduino or not. Now in this example I want to kind of take that idea a bit further. So I've now got 4 read switches connected to an Arduino Nano up here, and then they go round to ground again. And if you follow my channel a lot, you'll know that I do a lot with escape room puzzles. This is a very typical setup for an escape room puzzle where you've got 4 items with magnets in them and you'd have to place them against all of the read switches to solve the puzzle. So in the corner of the screen you'll see I've got the output from my Node-RED dashboard again, this time reading all 4 sensors. So if I take a magnet and I just pass it in front of each sensor in turn, you'll see that I can see on my web page in real time which one has a magnet up next to it. Now these are actually pretty strong magnets, and I've got these sensors quite close together on the board. So if you were doing this in a real puzzle, you'd probably want to spread these out slightly more to make sure you didn't accidentally trigger more than once. But hopefully, if I can get that to stay there, and then I could do this one here. So what you can imagine using this in is, let's say for a gamesmaster in a control room of an escape room, this is the puzzle that players are trying to solve. And by looking at this web page, you get a real-time update of which parts of the puzzle the players have done and which bits are still remaining. So here's the Arduino code. It's almost identical logic to what I used in the previous example with the single read switch. It's just that I've extended it to account for 4 read switches in this case. So right at the top of the code we've got some constants. We define 4 sensors. I mean, these could be any sensors, these could be buttons, levers, switches. I'm using read switches again, but I've called them sensors just as a generic input. And we also define an array of the pins that those sensors are connected to. So that's going to have the same number of elements in it as we have sensors, and these are the pins which I've got my read switches connected to. So I've got pins 4, 5, 6 and 7 on the Arduino, and then they're all connected to ground on the other side. We'll then record a global variable. Now we're using this to record what the last known state of each sensor was. So we initialize all of them at 0, and then depending on whether a magnet is touched to each one, so if a magnet is touched to the second one along, for example, this value might change to a 1. Or if we've got magnets connected to the last one, then this one will change to a 1 instead. So this records the previous known state of all of the sensors, and we'll compare the new state to that to see whether any of them has changed. Then we have our setup function, so this is what we run when the sketch first starts. We initialize a serial connection at 9600 baud. So this is so that we are able to send the values back to Node-RED through the USB cable which we've got connected. And we loop over all of the pins, so all of those sensor pins in that array, and we loop over them and we define them all as input pull-ups. So again, I covered this last time, but because when the read switch is not in the presence of a magnet, it's just an open switch. So the pin isn't connected to anything. It won't read high or low. It will kind of flip between them. So what we do is we define an input pull-up that's going to pull it up to a high value of 5 volts until the read switch is activated. And when it is, that will connect the pin through to ground, which will pull it down to 0 volts or low instead. So that's the setup. Now, what I've done here is I've actually separated out the function that sends the state over USB from the loop functions. What we'll do is we'll have a look at loop first, and then I'll come back to look at send state in a minute. So this is the loop function, which just loops over and over while the program is running. We'll define a Boolean variable, so a true or false variable, and we'll call it has changed. So what this is going to keep track of is have any of the readings of any of the sensors changed in this frame compared to the last known state of them. And we'll assume that they haven't, so we'll give it a false value initially, just assume that they haven't changed. And then what we'll do is we'll actually go and read them all and find out if they have changed or not. So once again, we'll loop over every sensor, so however many sensors we've got, we'll loop over them, and we will do a digital read of the sensor pin assigned to this sensor. So if this is the first time through the loop, we'll take the first pin, second time through the loop we'll take the second pin, then the third pin, etc, etc, until we've been through all the sensors. We'll read what the current reading is, so this is going to read low if there is a magnet close to the read switch, and it's going to read high otherwise. And then we'll actually invert that value, just because a lot of people find it easier to think of high meaning that a button has been activated and low meaning it hasn't. That just seems to be a bit more common sense. We'll compare that reading to the previous reading that we knew about for this sensor, and if it's different, so that bit there means if it's not the same, we'll set the has changed variable to true, and we'll also update the last state array to store the new value here. So we'll loop over every sensor in turn, we'll read it, compare it to what we last knew about this sensor, and if at least one of them has changed value, then we'll say has changed as true. Okay, so has changed means kind of any one changed. It doesn't mean that they all have to change, but at least one. And once we've done all that, so we've looped over every sensor, if that has changed variable has been set, then we know that something is different about the state of the puzzle, and we'll call this send state function instead. And then we loop over that and that again. Each time we assume that nothing has changed until we find otherwise, and then if it has, we'll call send state. Okay, so let's go back and see what send state does. And this is not too bad either. So once again, you'll get pretty familiar with this. We loop over all the sensors, and we're going to call the serial.print command. Now, serial.print you may be familiar with using to send values to a serial monitor, and that's generally what it's used for. So it's quite useful for debugging Arduino code, because you can look at the value that any variable has on the Arduino monitor. But what we'll be doing in a moment is we'll be picking up that value in Node-RED instead. So we'll loop over each sensor, and then what we want to do, because we're sending multiple values this time, we need a way of separating them. So this time we'll only loop up to number of sensors -1, because what we're going to do is we're going to insert a comma between every value and the next one, but we don't need to put a comma right at the end of the list. So that's why there's a -1 there, because we don't want to put one after every element. We want to put them after every element except for the last one. So we'll do a -1, and then we'll put a comma. And finally, after the end, serial print line. That means that we'll insert a line break, so we'll go on to the next line before sending the next state. So if I show you what that looks like, let me load up the serial monitor, for example. So this you might be familiar with, and let me also put on my display again, so there we can see. So if I show you the serial output as I hold my magnets up, so you'll see I've got 0001 there, because counting from the bottom up. Oh, actually, sorry, I'm holding my board the other way around than I was. Let me flip that around. So starting from the top down, so we've got 0001 when I hold the magnet there, and if I try to hold them one, so this will be 1000, 0100, 0010, and so on and so on. So a 1 means that that sensor does have a magnet in front of it, and a 0 means it doesn't. Okay, now let's look how we can get that into Node-RED. Okay, so I've got the Node-RED editor loaded up, and the first thing I want to start my flow is to insert a serial in node like this. Double click on it to configure it, and now if I flick back to my Arduino again, what we'll see is that this time the COM port that I was using to upload my sketch to was COM5. So I need to make sure I'm using the same serial port in Node-RED, so COM5, there we go. If that's not right, you can click here and change it to something else, but COM5 is the correct one for me. So there we go. So this is my start of my flow, is when a message has been received on that serial port connection, so sent from the Arduino. Now in the previous example, the next thing I did was sent that value straight to a text node in the dashboard, so I just did that. Now that's not going to work in this case because this serial value that I'm receiving is a comma separated list. It's actually got 4 values, so I need to kind of split them up into 4 different text nodes. So to do that, I'm going to insert a function node instead. So here we have a function node, and I'm going to connect my serial. So this is going to send the serial data into the function node. If I double click to the function node, we get to write a little script here. So what I'm going to do is declare a new variable, which I'll call output messages, let's say. And this is going to be an array because it's going to contain the split values from that combined value that's received. So we'll say values. So we'll take our message payload. So this is the this is the whole comma list which we received from the Arduino. First of all, we're going to trim it because we're going to get rid of any trailing new line characters or carriage returns which are sent on the end. And then we're going to split it by the comma. So the split command here, this is going to take a string and it's going to split it into an array based on whatever delimiter you specify here. So if we'd used, let's say, a semicolon separated list, or if we put a space or something else in between to separate our characters, you would just specify the delimiter you used there instead. So that's created an array called values. So now let's loop over values. So we'll take each value in turn, we'll call it v, and we're going to push into our output array. We're going to send a payload which is going to be equal to values v. I think I've written that right. Yeah, let me just check. So so we've created an array called values. We're looping over values and we're taking each one in turn and calling it v, and then we're going to take whatever v was and we're going to send that as a payload to output messages one at a time. So output messages is going to become an array of messages in which each element contains the value that we split out based on the comma. That's not very well explained to me, but hopefully that makes sense. And then instead of returning the single message, what we're going to return instead is the array. Yeah, I think that is probably right, so we'll click done on that. Oh no, hang on, one thing I've just realized is I need to increase the number of outputs because we're going to have 4 outputs coming out of here like that. That looks a bit better. Okay, so we've now got 4 outputs corresponding to the floor split elements that we split on comma. Now let's go back to our text dashboard element here. So let me just copy and paste that a few times. We're going to have 4 of those, and we're going to create each one connected to one of the outputs from our function node like that. Where we're going to put these, let's put these in the default dashboard group. You see I've got a couple of already existing ones there, but you can ignore those. Okay, let's try now. Let's just try deploying that and we'll see what happens. Okay, so it's connected. We've got our text elements. Swip it over to our dashboard. And then let me just put on my camera again. Okay, so here we've got the board, and if I take my magnets, you can see that we've got our 0s and 1s appearing in node red now. Okay, well that's all very well, but we could probably do with making that a little bit nicer formatted. So let's see what else we can do with it. If we go back to the editor again, and what we need to do now is we're going to insert a little bit of extra formatting between where the function node splits the message up and where they're sent to the text output. So let's actually break these lines here. And what we'll do instead is to add a change node, which is up here. And we'll connect that to the output. So this top one here, we'll just do this one to start with. And what we're going to do is we're going to, maybe we'll make the message appear in a different color depending on whether the read switch is on or off. So we're going to create an expression, and the expression is going to be if the message payload arriving at this node is a 1, so that means that the read switch has been activated, we'll say that the color is green, and if it's not, we'll say the color is red. There we go. And maybe as well, instead of just having the value 1 and 0, maybe we'll make that a bit friendlier as well. So we'll actually change the message payload based on the received value. So if the payload coming into this node was a 1 before, let's actually give it a nice name instead. So we'll say, I don't know, true or false. But you could write connected or not connected or activated or whatever you want there. So we're setting two different properties of the message. The first one, they're both based on whether the received value was 1 or not, but this one sets green and red, this one sets true and false. And remember, the way that Node-RED works is that the message flow gets passed along from left to right generally in the flow. So we started off, this was our array of values, then we split it based on the delimiter, which was a comma. Now we're modifying the payload, so instead of a 1 and a 0, we're changing it to a true and a false, and we're also adding a new property, which is going to be the color, so we called it message.color. And now, when this node receives the value, it can access the color which was set here. So let's go into our text, and we'll change this as well. So we'll actually label this so we know which one we're talking about. So we're talking about the read one. And now, instead of just displaying the payload like that, let's display the payload in the color that was set in the previous node in the flow. So this kind of double squiggle brackets here, this is how you insert an expression. So msg.color is what we set in the change node there. And then let's just close the font at the end there. Okay, done. And in fact, what I could have done, let me just copy and paste that, and we'll put that into all of the read switches. So this is read 2, this is read 3, and this is read 4. And then we also want to copy and paste these rules a few times. And we don't need to change anything about the rules because there's nothing here that's specific to the message. Every message needs to get processed the same way, basically. So we're going to just drag those there like that, drag those there like that, and then having made those changes, let's try deploying again. And then we'll go to the dashboard. So you'll see that the labels have been updated with those new labels, read 1, read 2. We've now got coloured words false because at the moment none of them are connected, but if I take my magnets again, I just try and secure them onto these read switches, you'll see that as they change values, we've not got zeros and ones, we've got trues and falses, and they are in green and red. So that's how you can create a Node-RED dashboard which receives multiple values from an Arduino. They were sent as a comma separated list. We've split them out in Node-RED, sent them to different labels, and we've also applied a little bit of conditional formatting just to make it easier to see what those values are. And that's it. Thanks very much for watching.